Best greetings to everyone. Hoping you are enjoying, hoping you are well and safe anywhere, everyone. We are continuing with the crystallizing M1 paper, October 2024. We are on question 2. We recognize directly that this is talking about moments. We read the question sufficiently, focusing on the key statements, resolving as we'll be doing in the next few minutes. Let's crystallize question 2. A non-uniform beam. Non-uniform means the mass or the center of mass is not in the middle of the beam. AB of length 6 meters as shown and mass 50 kilograms. The beam rests horizontally on two supports, C and D. So directly we have reactions. Label directly while you are reading. 0.9A from C, D from B is 1.8 meters. A child of mass 25 kilograms stands on the beam at E. So directly you write his weight or the particle weight, where AE and EB are equal, and each one of them is 3 meters. So this means Mr. Child here stands in the middle of the beam. A beam is in the equilibrium, RC, RD are shown. The beam, of course, is modeled as a rod, and the particle has a weight like we did. So this is here 50 G, which is the weight of the beam. Here's important key statement. The center of mass of the beam is between C and D and is a distance of X meters from D. So show yourself and the examiner that this is X meters. Given that, he gives me a algebraic relationship between RD and RC by making one of them in terms of the other. So RD equals 3 over 2 RC. Show that this X is 1.3.8 meters. Directly, once the question is talking about moments, we write two equations. So first step, we write the equation of forces. Sum of forces upwards equals to the sum of forces downwards. Two forces upwards, which are RC and RD in the same direction, 25G plus 50G downwards, which are 75G newtons. Then you use this algebraic relationship to write this side in one unknown, which is RC. I decided, it's up to you, plus 3 over 2 RC equals 75G. By simplifying left-hand side, getting 5 over 2 RC equals 75G. Calculator if you are not fast, guys. Don't do mental if you are not that good. RC in numbers, which is divided by 15, 30 G newtons. By replacing 30 G newtons into this formula here, getting RD is equal to 3 over 2 times 30 G, which is 45 G newtons. Continuing second step, which is the moments. Writing the values here if you don't have that good memory. RC is 30 G, RD is 45 G. Then you label them with the values now. So this is 30 G, RD is 45 G. Then you decide about what point or which point you take the moments about. I'm just showing you what I did there fast. So I will decide most of the questions we do the moments about the ends. So we'll take it at E this time. When you decide this, draw an arc from each vector here, each force, except the force on the point has no moment here. Its moment is 0. So leaving 3 forces, 50G first, its direction is anti-clockwise, and this one as well is anti-clockwise. So you have two forces, 50G, and what's the distance from 50G and E? From 50G, as he said, is X. From E and D, 3 minus this, which is 1.2, gives you X minus 1.2. RD, which is 45G in the same direction, which is 1.2 meters from E, equals this force, only one force, which is clockwise, which is RC, which is 30G. And 30G, how far from E? From here to here is a 3. 3 minus 0.9, 2.1. Now using the calculator, but noticing that G is a common factor, simplifying to 50 times X minus 1.2 plus 45 times 1.2 equals 30 times 2.1. Calculator now by expanding 50x. 50 times 1.2 is 60. 54, which is 45 times 1.2, 63. So 50x equals 99 minus, which is 69. Use the calculator, as I always telling you. 69 divided by 50, which is 1.38 meters. Finishing part A. For part B, the child remains at E. New information now will be coming. But the child will remain at E. And a block of mass m kilograms is placed on the beam at B. The block is modeled as a particle. This means it has a weight. Just he's reminding you. Given that the beam is on the point of tilting, find the value of m, which is the mass of the new block. I prepared for you here another one to help you and as a student at the examiner to understand what you are doing. He said this is particle m, so it has a weight mg at B. He said Mr. Child stays, so this is 25g, and of course the weight 50g, which is 1 point now, 1.38 from D. Dear students, when the particle or block M at B, what would this tell? Or what should this tell even? That Mr. Beam will be tilting, so since M on B, so the beam is tilting or is about to tilt about D. To show you what's happening here, that will happen. If some of you not involved with tilting, dear lovely engineers and doctors, so particle D beam, the beam will be tilting, means it will be standing on D, and Mr. C support C, no force. So this will tell the reaction of force is 0. No reaction to the pole, since now it's far. It's not resting or it's not supporting anymore. With showing the distances, so first information that when the beam tilts about D, that you got. Second step, directly, dear lovely students, every question with tilting, take the moments about the point of tilting after you understand that the beam will tilt about this point, which is D in this question. What would this tell? RC is gone, as we said, no effect. RD, of course, now what will happen since you decided RD is also the moment, its moment is 0. So this is leaving 3 forces. the new one, and this one, and this one. By showing about D, the moments, this is the direction of this force, and these both in the same direction. So mg is clockwise, the moments now the sum clockwise is equal to the moments anti-clockwise. So mg is the only one, its moment is anti-clockwise, which is 1.8 far from D. 25g, which is from D, is 1.2 plus 50g, we just found it, which is x, which is 1.38 meters. Solving this for m that he wants, g again is common factor, so this will imply that 1.8 m equals 25 times 1.2 plus 50 times 1.38. Using the calculator, of course, you will get this is 1.8 m equals 69. Sorry, this is 30 plus 69. So m is equal to 99 divided by 1.8, 55 kilograms. Finishing A and B. Stay updated, guys, to do crystallize like this all the questions, the ones more difficult than this in the variant units or chapters. As usual, leaving you with well and safe, and hoping everyone you're getting your desired grades, finishing your exams with pride and success.